Kia ora. This is an example of a video that you could submit for this 90931 standard. Notice that I have a title and that I have my name shown on the slide and either a reference to the standard number or to the coding we use, which is CHO1021Y1. Then give a little bit of a background. You can use photos off the internet as long as you sort of refer to them if you want them count towards the standard. Now, this is just the background, so basically we're saying we can use acids and salts to preserve food, and that's as much as you need. But you need to describe the chemistry on the macroscopic, which is describing it. So you could talk about your color changes to show what is an acid and what is a base. Do it on a microscopic or submicroscopic level, so you show your particles, your hydroxide, your H+, and your salt things. And then also on the model, which is the formulae and the equations. So you would talk about defining your terms. What is an acid? What is a base? What is a salt? Pretend that your teacher knows nothing and you've got to tell them everything you've learned in your level 1 chemistry. So you talk about your pH and how to measure and know what's an acid and a base because of its color and so on. Then here's sort of more examples of the particle level, the microscopic level. Try and explain your chemistry, what's happening to all those little particles. Also with the model level, add equations, but follow your chemistry conventions. Use superscripts and subscripts and formulae. Balance your equations and use arrows in equations. Equals signs or no, you don't use it. Then remember all your terms that you've learned. Show that you've understood cation, base, polyatomic, anion. Show that you know all this. And you can have pictures, refer to them. So this is where it used to be mined. Sodium nitrate used to be mined in Chile and Peru. It's not used there anymore. They actually now still get lithium for your mobile batteries and mobile phone batteries there. But we now make sodium nitrate in a laboratory. So these last two equations are the most common ones, where we use a carbonate or a bicarbonate or hydrogen carbonate, so sodium carbonate, sodium hydrogen carbonate, to make our sodium nitrate. And because we've got a carbonate, explain that you've also got carbon dioxide. You can talk about the test for carbon dioxide and how you know it's carbon dioxide if you want to. If you don't have a carbonate, you've got a hydroxide or an oxide, remember you don't make the carbon dioxide. So show you understood all that and know that. Also show that you know that it's a neutral salt. Again, with your pH, so you can see this universal indicator is green for sodium chloride and sodium nitrate. Not all salts are actually pH of 7, so don't assume that. In this case, when you're trying to explain the chemistry, the key property why sodium nitrate and sodium chloride can be used as food preservatives is because they are so soluble. So you would explain about the solubility. You would refer to the modules where it talks about the solubility rules. That's in the chemical detective series, CHO1051Y1. You'd refer to that. And you can see here, I've got an image showing all the sort of particles they've separated out. I had a solid altogether, but when something dissolves, it breaks up into the individual ions. Now you talk about it as a food preservative and you refer to the solubility because by sprinkling it with the sodium nitrate, it draws the water out of the food. It becomes more concentrated on the surface than inside, so it draws more water out to try and equalize the concentration, and that's called the process of osmosis. So you can define that term. And of course, the water that's being drawn out is constantly evaporating, so you would explain all that. If you had thick pieces of meat, you would just simply immerse it into that solution so that there's time for that sodium nitrate to go all the way through. And how does that work? It's because the sodium nitrate is antimicrobial. Remember to use also good biology, put any species, biological species in italics, and explain, the term anaerobic, although you wouldn't need it for the chemistry because you're doing a different topic. But you would talk about a decomposition reaction in this case that makes oxygen, and therefore that's not anaerobic because anaerobic means no oxygen and I'm producing oxygen. And my nitrite that's over here can break down further to form nitric oxide, which can bind with your iron in your blood to make that meat a nice, attractive red brown. And there are other ways it can also help preserve the meats. You can go to as much depth as you like. Finally, finish your video with a summary. So everything you've spoken about, repeat again very briefly. So remember, title, your name on it, an introduction, brief background, focus on the chemistry of how that substance can be applied to its use, or if you were choosing how something is made, like how is petrol produced or how is steel made, you would be focusing on the process of how it's made, or the chemistry of how it's made, and therefore, and also a little bit of how then steel is used or petrol and diesel are used. So all the best, and it'll be lovely if we can also see your faces if you use your webcam. Kia ora.